Good day, everyone. I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about the angle of depression. Now, in our previous lesson, we've also discussed the angle of elevation. Now, both of this lesson are the application of the six trigonometric ratios and also the special right angles of a right triangles. So let's define first what is the angle of depression. The angle of depression is the angle between the horizontal line. So we have here the horizontal line or the eye of sight, the eye level, sorry, and the eye of sight. So we have here the eye of sight. Okay. So it is basically used to get the distance of the two objects where the angles and an object's distance from the ground are known to us. If the object observed by an observer is below the level of the observer, then the angle formed between the horizontal line and the eye of sight is called the angle of depression. So let us recall first what are the steps in solving math problems involving angle of depression. So it's the same in the angle of elevation actually. First, we need to draw an illustration that visualizes the problem and label it using the given information. Second, we need to formulate a ratio of the given measure and the variable representing what is being asked in the problem. Third, form an equation using the formulated ratio and the trigonometric functions define the ratio. And fourth, solve the solution of the equation and the solution of the problem. And last, we need to label your final answer correctly. So let's also recall that we need to consider the following reminders to determine the function used. First, if the measure of the leg, either of the leg and the hypotenuse of the right triangle are given, then we need to use sine or cosine function. Second, if the measure of both legs of the right triangles are given, then we need to use the tangent function. So let's have example number 1. An airplane is flying at the height of 4 kilometers above the ground. The distance along the ground from the airplane to the airport is 6 kilometers. What is the angle of depression from the airplane to the airport? So we have here the illustration, the airplane and the airport, and also the given distance of the we have here the airplane flying at the height above the ground with 4 kilometers, and the distance along the ground from the airplane to the airport we have 6 kilometers. Now the question here is we need to find the angle of depression. Now let's recall first our grade 8 lesson about two parallel lines cut by transversal line. So we have here the line of sight forms a transversal line, that is the line of sight here, of the two horizontal parallel lines. So we can create also the two horizontal parallel lines here. As a result of that, the angle of elevation and angle of depression all are alternate interior angles. Which means that alternate interior angles, that means they have the same or congruent angle sila. Since the transversal intersects to two parallel lines and the alternate interior angles are congruent, the angle of elevation and angle of depression must also be congruent. So that means the measure of the angle here is also congruent or equal to the measure of angle here. Since we need to find the angle of depression now here, but the givens are in the opposite of this angle. So that means they are alternate man, the angle of depression and the angle here. That means we can also identify or to find the given measure of the given angle, we need to use this angle. So what function we will use? So the angle A is the opposite of the angle A is the opposite side, 4 kilometers. And the adjacent side is 6 kilometers. So we will use TOA or tangent. So tan A is equals to opposite over adjacent. So next, we need to substitute our given. So we have tan A is equals to 4 kilometers over 6 kilometers. To find angle A, we need to use tan inverse to find angle A. So angle A is equals to tan inverse. Then we need to input 4 over 6. So you can use your scientific calculator in finding this one. So what is the tan inverse of 4 over 6? We have angle A is equals to 33.69 degrees. That means the angle of depression from the plane to the airport is 33.69 degrees. And also here, in the angle of depression, since they are congruent, the angle also here is 33.69 degrees. Okay, let's proceed to example number 2. From the top of a cliff, we have 280 meters high. The angle of depression of the boat is 25 degrees. How far from the base of the cliff to the boat? So first, we make an illustration. So we have here na the illustration of the cliff and also the boat. So the cliff, the height of the cliff is 280 meters. And the angle of depression of the top of the cliff to the boat is 25 degrees. And also here, what is the question is what is the distance from the base of the cliff to the boat? So since here we have the angle of depression 25 degrees, again, since angle of depression and angle of elevation are congruent by the theorem of two parallel lines cut by transversal line, so that means we can use this angle here as our reference angle in finding the distance of the cliff from the base of the cliff to the boat. So that means the opposite side is the height of the cliff, 280 meters, and the distance from the cliff to the boat is x. So that is the adjacent. So we will use again TOA, or tan theta is equals to opposite over adjacent. So tan 25 degrees is equals to 280 over x. Cross multiply, we will get x tan 25 degrees equals to 280. Divide both sides by tan 25. We have here x is equals to 280 over tan 25 degrees. So you input that one in your scientific calculator, you will get x is equals to 600.46 meters. That means the distance from the boat to the base of the cliff is 600.46 meters. Now let's proceed to example number 3. From a hot air balloon that is flying at a height of 100 feet, the angle of depression of the person to the ground is 30 degrees. Find the length of the rope that is tied from the person on the ground to the balloon. So we have here the illustration, no? So the distance, the height of the hot air balloon to the ground is 100 feet. And then the angle of depression of a person on the ground is 30 degrees. So we have here, find the length. Now we need to find the length of the rope to the hot air balloon that is tied in the person. So that means the angle of depression is 30 degrees. And then we have also here, that means there are alternate interior angles. That means they are congruent. So that means we can use this as our reference angle. So the opposite side is 100 feet and the hypotenuse is the x, or the distance or the length of the rope that is tied from the person to the balloon. Okay, so we will use, so what will we use? So opposite and hypotenuse, so we will use sine theta. So sine theta is equals to opposite over hypotenuse. So we have sine 30 degrees is equals to 100 over x. So cross multiply, we will get x is equals to 100 over sine 30. So you input that one in your scientific calculator, you will get x is equals to 200. So that means the length of the rope that is tied from the person on the ground to the hot air balloon is 200 feet. Let's have our last example, example number 4. An airplane is flying at an altitude of 15,000 feet. The angle of depression to the nearby air tower is 20 degrees. What is the distance along the ground from the airplane to the air tower? So we have here the illustration. The airplane, we have the altitude of 15,000 feet and then the angle of depression is 20 degrees. So since we have here, and also what is the distance along the ground of the from the airplane to the air tower, we have here. So that means the question is we need to find this side. So since the angle of depression and the angle here are alternate interior angles, that means they are congruent. So we will use this one as our reference angle. So we have here the opposite is the altitude of the airplane, and the adjacent side is the distance along the ground from the airplane to the air tower. So we will use tangent. So tan 20 degrees is equals to 15,000 as the opposite side and x as the adjacent side. So we have here x cross multiply, so x tan 20 is equals to 15,000. Divide both sides by tan 20, we will get x is equals to 15,000 over tan 20. So you input that one in your scientific calculator, you will get our x is equals to 41,212.16. That means the distance between the distance along the ground from the airplane and the air tower is 41,212.16 feet. Thank you so much for watching our video. I hope that you've learned something out of it. So please don't forget to like, subscribe, and also if you have comments, so you can comment down. Thank you so much, and God bless everyone.